All right, so we are going to do something new for the next 2 days. So I was technically going to show you guys this when we did our unit on bonding. However, we just ran out of time, but now that we have a little extra time here, we're gonna go over it today and tomorrow. And guys, I want you to think positively because this is so easy. When you don't overthink it, it's actually super easy, okay? So first things first, this essential question says, what is electron configuration? And all it is the arrangement of electrons in energy levels. And remember, what are energy levels again? Energy levels are shells. Remember the rings in an atom? So there are these things called sublevels that are within each energy level. And it's kind of hard to see unless I saw you guys in person. If we had like a bunch of balloons, I could maybe like illustrate that for you. But within each shell, there are sub-levels or sub-shells. Sub meaning, remember, what does a submarine do? It goes underwater, right? So sub meaning beneath. So beneath these energy levels are each of what we're going to talk about today. So each energy level is divided into sub-levels, and that's like, if you get anything today, if you remember like, oh, she said something about sub-levels in S, P, D, and F. Perfect. Then we hit our objective for today, okay? So this is how electron configuration is written. In other words, guys, this is another way of just identifying an element on the periodic table, and you use your periodic table to do it. So how is it written? So this big 2 on the left side, this is the energy level. Or in other words, guys, how do we tell number of shells on the periodic table? The period number, okay? And you'll see that trend here. This letter, so for here it's P, this is the sublevel or the suborbital, or however, there are multiple terms for it. So sublevel can be S, P, D, or F. Okay, those are the 4 things. If you remember, just 4 sublevels we talked about today. And then this number, which is the exponent, is the number of electrons. Okay, remember this. You're gonna have this for your warm-up tomorrow, so just a hint there. Okay, so this is our periodic table. This is how it's divided. So groups 1 and 2 consist of the S block, is what it's called. So anything in these 2 columns are considered S. We're in the S sublevel, okay? Helium is also considered in the S, so it's one of those, like, remember, kind of lone wolves here. It's technically a part of the S block. This whole block right here is considered the P block. The transition metals are the D block, and then the bottom, like the rare earth metals, are the F block, okay? So when we look at each of these orbitals and sublevels, each of them can hold a certain amount of electrons. So the S block can hold, so any of the elements here can hold 2 electrons in that sublevel in the S block. P can hold a maximum of 6 electrons, D can hold a maximum of 10 electrons, and F can hold a maximum of 14. Now, I know this sounds like Chinese to you, but once I do a few examples, you'll kind of get the idea. What's most important is that you remember where the blocks are on the periodic table, because that's exactly what we're going to use. Because if you don't notice here, so the S block, right, consists of groups 1 and 2 here. Notice that S can hold a maximum of 2 electrons. So you can literally just use the periodic table to count your electron configurations. And again, if that's Chinese, or if that doesn't really make sense, or Mandarin for certain students who will correct me on that, it is Mandarin. So if that sounds like another foreign language, point being, then it'll make sense once I do it. But notice that trend. For P block, which can hold a maximum of 6 electrons, the P block consists of this block right here. And notice if I count these elements, I have 1, 2, 3, 4, 5, 6. So notice that there's a trend with how many maximum you can have and what's on the periodic table. So examples. So write the electron configuration of, let's look at nitrogen. Okay. So first things first, you need to identify your destination, is what I call it. Okay, so our destination is right here, nitrogen, right? So before you can get to nitrogen, consider it like reading a book. So you read from left to right and you go row by row, okay? and you just keep track of what block you're in, and then that's how you write the electron configuration. So before I can get to nitrogen, I have to go through this first row. So I go through, this is period 1, so 1s1, 1s2, but I passed those, so you write it down. So it's 1s2. Again, I know that might be confusing, but you'll get it the more we do it. So 1s2. So we move on to period 2, so we're in a new period, so that first number is going to change. So then we're still in the S block, 2s1, 2s2, and we're not there yet. We're not to nitrogen, so we're going to write 2s2 down. Okay, and then notice as I'm now in the what block according to our notes. This is the P block, still in row 2, so I'm in 2p. This could be 6, but I need to stop at nitrogen, so then I just count 2p1, 2, 3, 2p3. Now, a good way to check yourself with all of this is to count all of your electrons. For nitrogen, we should have how many electrons total? The atomic number is 7. We should have 7 electrons. So if I count all of my exponents, I should have 7. 2 plus 2 is 4. 4 plus 3 is 7. So we are good. That's how you can check yourself. Okay? But Miss, how do I keep track of these big numbers? Again, it's by period number. How do I keep track of what letter I put or the sub-level? It's based on these S, D, P, and F blocks. This is how the periodic table is organized. So let's try another one, and we'll try a few until it makes more sense. So let's do phosphorus. This one's a little more lengthy. So phosphorus. Again, I'm trying to get to P here, right? And I need to get through all of these. Like, you need to consider all of these sub-levels as well, because all of those shells are included. Remember when we were drawing Bohr model, when we were drawing all of each energy level, you have to consider all of the other ones that are already there, right? So that's the reason why we have to write everything down. It's pretty much like electron configuration is like those of you that have really long names, for those of you that have like 2, 3, 4 names. It's kind of like writing your full name is what electron configuration is, okay? And it's a way of identifying and locating electrons. So, phosphorus. So I'm gonna go through 1, we're in row 1, so 1s2, we're still not there yet. So we write down 1s2. We are now in row 2, 2s2, because we're in the S block there, 2s2. Now we're in the P block, so still in row 2, 2p6, and we're still not at phosphorus yet, 2p6. Row 3 now, moving on. So row 3, S2, we're still not there. Still in row 3 until we get to phosphorus. Still in row 3, P1, P2, P3. We stop. We don't have to write P6 because we only have 15 electrons to account for. Okay, so P1, P2, P3, 3P3. Okay, how many electrons should I have total? I should have 15. I should have 15 electrons, and if you count all of your exponents, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 3 is 15. Boom. That's it, guys. This is what electron configuration is, the ground state electron configuration. So I'm going to do a few more, and I want you to try these on your own and pause the video so that way you can get some practice in. So try magnesium and try calcium. Okay. And then the D and the F blocks have their own rules. So I won't have us do any crazy D or F blocks just yet. However, they're not difficult. It's just a simple rule that you have to remember when you're writing electron configuration. Now, magnesium. Okay, so magnesium, again, I need to account for all of the ones before it. So I'm going through the S block first. So I have 1, S1, S2, which is helium, still not there, so you write it down. So we have 1, S2. Then we have 2s2, 2p6, 2s2, 2p6. Then we have 3s2. Notice magnesium is here, so we stop. So 3s2. Okay. Count up all of your electrons. So we have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. So we have 12 electrons. If you check yourself, magnesium is atomic number 12. We're good. That's it. Okay. So calcium, I want you to do that on your own. And it's going to be longer. Okay. But that's the pattern, guys. As you get into the D block, the main, I haven't taken a look. I need to look at that practice a little more closely. If you do have any that involve the D or the F block. The trick is that you need to drop an energy level. So even though I am in row 4, this is actually going to be 3D. Okay, and row 5 is going to be 4D, row 6 is going to be 5D. Why, Miss Maitza? Because of the nature of the energy levels of the D block. Okay, and then for the F block, you need to remember that these are technically, remember how I told you guys at the beginning that these are kind of shot out from this area right here? The only reason why it's not in this little area is because they didn't want to make the periodic table longer. So right here, this is considered row 6. This is considered row 7. Okay, so keep that in mind. And they also, there should not be any F block just yet. So we'll get to F block when we get there. There might be some D block in there. If there's D, drop an energy level. So this would be, once I get to 4s2, this would be 3d, 1, 2, 3, 4, or whatever it is here, whatever element you're trying to find the electron configuration of. If that didn't make sense, come see me on Zoom and I can help you a little bit more with that, okay? But that's pretty much it with that. Go ahead and do your practice based off of these notes, and then that's all, guys. All right, see ya.